Here is another beautiful question from IBHL math test paper. We need to find the equation of tangent to the curve y equals to 5 to the power of minus x square at the point on the curve x equals to 1. Graph the curve and the tangent at this point. That's the second part of this. I'm Anil Kumar. Welcome to my YouTube channel, absolutely free for last 15 years, a learning platform where you contribute. Now let's begin with the solution of this problem. So we are given a function which is y equals to 5 to the power of minus x squared, exponential function. And at the point x equals to 1, we need to find the equation of tangent line. So let us find the value of y at that point first. So when you put x equals to 1, y will be equal to 5 to the power of minus 1 squared, which is 5 to the power of minus 1 or 1 over 5. And therefore, we get the point, let's call this point as p, will be 1 over 5. Perfect. So we have a point on the curve. And now, to find the equation of tangent line, we'll find the derivative. So, next step, derivative. I hope you remember the formula. So for any exponential function, when you take a derivative, you get the function itself with ln base and the derivative of the function which is there at the exponent. So the derivative of this function will be 5 to the power of minus x squared, right, times ln 5, which is the base, times derivative of minus x squared, which is minus 2x. So that becomes the derivative of the function. Let me rewrite this as minus 2. Let me write x first here, and then we'll write 5 to the power of minus x squared ln 5. Great. So we have the derivative. Since we are interested in finding equation of tangent, let's find the derivative at x equals to 1. So if I substitute x equals to 1, then at x equals to 1, the derivative will be minus 2 times 1 times 5 to the power of minus 1 square, right, ln 5. So that is 5 to the power of minus 1 square will be 1 over 5. Right? So we get minus 2 over 5 ln 5. Right? So that becomes the derivative of the function at x equals to 1. Now to find the equation of line, we can use y minus y1 equals to m times x minus x1. So let's do that. So we have equation of line now, tangent line. And the point P is 1 by 5. We are using the formula y minus y1 equals to m times x minus x. Point slope form. Okay. So we get y minus y1 is 1 over 5 equals to gradient, which is minus 2 over 5 ln 5 x minus 1. So that gives you the final equation. We'll rearrange y equals to minus 2 over 5 ln 5 x, right, minus and minus becomes plus 2 over 5 ln 5 and we'll get plus 1 over 5. Correct. So that becomes the equation of tangent line. So with that, we have done the first part, that is to find the equation of tangent line. And now, the other part is to graph this particular function. So I'll give you suggestions how to do it and leave this exercise with you, right? So this is what we got so far. So let's talk about the graph of this particular function, which is y equals to 5 to the power minus x squared. You see it is an even function, right? Means if I say what is f of minus x in this case, I get the same function, right? Which is f of x. And therefore, it's an even function. So that really means that I could actually graph it for x greater than equal to 0. So take some points and graph it. So especially if you take 0, anything to the power of 0 is 1. So let's say f of 0 is what? It will be 1, right? So we get 1 point here, which is 1. We have the derivative, and from the derivative we can do the analysis for maximum, minimum, and you'll find that this 1 is actually a maximum. This is also a maximum. So I'll like you to verify this. So that's first part, and then you do concavity, right? So find the second derivative, right? And once you do that, find concavity. So notice that the graph actually kind of goes like this on the right hand side. So now as it goes like this from 1, what you need to do is work out some points. On the left hand side, it will be symmetry. You get the whole idea. And somewhere here at 1, you can form the tangent, which will be going from lower side of the graph. You get the whole idea, because the graph is concave down before this point, and therefore that is how you're going to see the tangent. So I'm giving you details of how to do it, not doing it actually, but here is how it is going to look. You see, this is the point at 1 where we have drawn the tangent, and the equation is just as we derived. So I hope you got these steps. So you have the first derivative, also find the second derivative. It's easy. Those are the constants, and exponential functions kind of repeat. Great. So from here, find critical number. That will give you a point of inflection, and then you will get a better look at the graph, and also we figured out that's an even function. Well, still, if there is a problem, just you can always email me on globalmathinstitute@gmail.com. I hope that helps. Feel free to write your comment, share your views. If you like and subscribe to my videos, be great. Thanks for your valuable time, and all the best. Follow my book and bring alive the real experiences. Thank you, and all the best.